Hello and welcome to a very quick tutorial for you on saving objects in Java. This is going to be a quick demonstration on how you can take an object, so anything you'd be working with in Java, turn it into a file and then retrieve it at a later date. This is more or less the simplest way to create persistent data in Java, and we're going to be using the native serializable interface, so you don't have to worry about libraries or packages or making compilation a bit harder at the end. Now to start off, I've created a simple class. This is going to be a dog class, and that's what we're going to save to a file. There's nothing particularly special about this class. Each dog object is going to have a name and an age, and I've just created a few simple methods here, getters and setters, and of course a toString. So let's start off very simply. In our main method, let's create a dog. New dog. I've called him Rover, and his age is going to be 5 years old. And now quickly to verify that everything's working as it should be, let's do a quick System.out.println, and we're going to print Rover. I'll quickly run this, and we can see down here we've got a dog whose name is Rover and who's 5 years old. That's all fairly simple so far. The next step is going to be saving our Rover to a file. In our program, we've created a dog object. This object has attributes, in this case a name and age, and what we want to do is turn this object into a set of bytes, which we're then going to save onto our hard drive. Turning an object into bytes is known as serialization. Now when we stop our program or even turn off the computer, this information is saved on our hard drive. When we restart the program or even want to access it in another program, we can take this information and turn it back into an object on the Java virtual machine. This serialization is how we're going to save our data in a persistent manner. The first step in this process, we're going to go into our dog class, and really any class, any object that we want to be able to save to a file, we need to add this line to its declaration, and that's implements serializable. If your class already implements other classes, so you've already got your polymorphism in there, you can add this to the implementation. Java does allow for multiple implements. But any file or any object that we want to save to file has to have this implement serializable in the class declaration. We don't need to change anything else about the file, that's all handled behind the scenes. There are methods you can overload, but that's really outside the scope of this video. So now we've got our dogs implementing serializable, let's hop back into our main method. So we've created Rover, and now we want to save Rover to a file. First off, let's say we are saving, and I'm going to create a try catch block. We'll see why in a bit, but saving to file is relatively simple. We start out with a file output stream. That's our file saver. It's going to be a new file output stream. And this takes the file name that we want to save as. So for me, I'm going to save this as Rover.dat. There's no restrictions on what you call it, what the suffix after the dot is. I'm using .dat because I'm saving it as a data file. You could go for .bin, you could go for .dog for all it matters. What a file output stream does is it takes data, so a bunch of data, there'll be ones and zeros, and turns it into a file on your hard drive. By default, this will save it in the root directory that your Java program is compiled into. So next off, we're going to need an object output stream. I'll call this the object saver. Now what this does is it takes an object, so that's any Java object, and turns it into the data, into the ones and zeros that the file output stream can then put onto your hard drive. So this is a new object output stream, and what this takes is our file saver as an input. So we tell it where we want it to put the data after it's turned it into data that the file can save as. The next step, we want to take our object saver and write an object, and the object we want to write is Rover. Now you can write any object that implements the serializable interface. Finally, and this is more politeness than anything else, we need to flush the object output stream. This just says, take the object, push it through the process, and finally close it. Both of these are more politeness than anything else, but on bigger projects, because we're just saving one object, we could probably get away without doing it. But on bigger projects, you're going to end up causing errors if you don't properly flush and close your output streams. Now you can see we've got a whole bunch of red squiggles here, and that's because just about all of these throw IO exceptions. Now this isn't the most graceful way to handle your exceptions, but for now it's more or less what we're going to be dealing with. You probably want to make sure that if an object isn't saved properly, you have some way of knowing that, of recovering the data. But for now, all we're going to do is I'm going to print out System.err.println, and Rover was not saved. And I could do a little crying face. Now, assuming all that has worked out, I'm going to do a quick System.out.println and say Rover saved successfully. And that's all we need to do for turning a object, a dog object, into a file which we can then use at a later date. It is fairly simple. Sorry if it's gone through a bit fast, but you can just go through. All we need is to make sure that the object implements serializable, and we just use this little block of code here to save it to a file. Now I'm going to run this. Takes a few seconds. So it's saving, did save Rover successfully, and I can see now in my file tree that Rover.dat's been created. Now we take a look at Rover.dat and we can see that it is a mess. We've got a whole bunch of non-printable characters, letters with accents. There are some words that we can recognize, so I can recognize the word dog there, age, name, library java.lang.string, and the name Rover. But this isn't designed to be read by humans. This is for Java to read. And that's why it doesn't look very good to the RI, but that's because it's really not for us to read. It's for Java to use later on. So we can pretty much ignore that for now. All we know is the data we care about has been saved. The next step is going to be loading it up. What I'm going to do for now is I'm going to comment out all of this. We need to be clear that we're not creating anything new here. What we're doing is going through that second step of the process of taking Rover.dat, using it to load up a new object which has the same data that we saved earlier. So, first part of the step, let's quickly create a little console output saying we are loading a new Rover. And I'm going to create a dog loaded Rover. And I'm just going to initialize that for null for now. This is just because we are loading stuff in a try-catch block. So, first in the try is we're going to need, and you'll see this is the mirror opposite of what we did to save, a file input stream. I'm going to call this the file loader. It's going to be a new file input stream, and we need to tell it where it's loading from. And of course for us that is Rover.dat. Next, as you can guess, it is an object input stream. It's going to be the object loader, the new object input stream, and that takes our file loader. See, it's all fairly simple. The next step is where it differs a little bit, is we are going to need loaded Rover to be equal to object loader dot read object. And finally, again, it's these politeness methods. We are going to close up our object loader. So we've got some red squigglies. Let's make sure to catch an IO exception. If we get an IO exception, I'm just going to print out to our error log Rover was not loaded. Let's have another sad face. We shouldn't see these. And there's another error we need to catch here, which is a class not found exception. Now, that's much more specific to what we're doing here. And that is, if we try to load this in another program where we haven't said what dog.java is, we haven't declared the dog class, then it will try to load it in, but it won't really know what it's doing. So it's important that you make sure to declare all of the classes that you're loading in. We'll also get a similar error if I change my dog.java class. So if I go in here and I add more data, for instance, I say that dogs have a squeaky toy, then it won't know what to do with the file we created. So it is important that any files you create are loaded in using the same version of the class that it had before. For now though, we're not too worried about that, so I'm going to create another error message here that says dog.java does not exist. Again, we're not going to run into this. Finally, let's do a System.out loaded successfully, and might as well print out loaded Rover to see that we've loaded it in. You might see I've still got this one red squiggly line here. The reason we've got this is because the object loader loads objects. If you remember from learning Java, every non-primitive, so everything besides integers, characters, bytes, is an object. So pretty much everything we work with in Java is an object, and the object loader loads in objects, so any class inherits from it. Problem is, loaded Rover is a dog, so we need to say we don't just want an object, we want that object to be cast to a dog. So we put in this cast declaration here, and this takes this object and it says this isn't just any object, this is a dog, and that way loaded Rover can accept it. We could just work with the object, but eventually you're going to want to cast it down because you can't work with just objects, or you shouldn't work with just objects. Now that's all sorted out here. This is everything we need to load in a file. Going to run it again. Takes a couple of seconds, so it was loading new Rover, loaded successfully, and it has loaded in a dog named Rover with an age of 5. So that's taken our file that we saved to the hard drive. All of this has been commented out, and it's loaded it in from that file. We've not told it to do anything. We've not declared the name or the age anywhere else. This has taken it from the file, turned it into a new object. So at this point, you have everything you need to save and load objects from files. I'm going to spend a little bit more time going into how we can clean this code up, so it's a little bit more usable. You might choose to use it a bit differently, and also some of the problems that you can quickly run into, because this is by far and away a place that you need to be careful. Saving and loading files will cause problems if you're not keeping it clear in your mind what's going on. So to start with, we are going to clean this up a little bit. You don't really want to have massive blocks of code anytime you want to save or load something. And the way I'm going to do this is I'm going to create some methods. You probably don't want to do this in your main class. You might create a class called IOHandler. But for now I'm going to put it in the main class because where it ends up is more down to the implementation. So let's start with public static, and it's going to be void because it's just saving. saveObject, and this is going to take a serializable. Like we said, anything that we want to save has to implement serializable, and it's going to take a file name. Now we can more or less just copy all of the code from up here to save these red squirrelies. Let's just throw the IOException down the road. We don't want to handle it in this method. We're going to write the generic object, and we're going to make sure that everything isn't just saved to Rover.dat. So this means that instead of having this big block of code here, I can just do saveObject Rover to Rover.dat, and that's cleaned that up nicely. we'll create a second method called public static. This one we want to return, and I'm going to be using generics for this one. If you've not run into generics before, don't worry, you can just replace this with dog or serializable. But we're going to assume that anything that we create or anything we load is going to be loaded into the class that we care about. So we do this with this little angle bracket. T is the sort of standard, but you can write anything in there. And this is going to take a file name. And this just says we'll take a file name and we'll return whatever you want us to. We're going to copy this section here. This loads in the file from the file name given. We're going to say that it throws an IOException and a class not found exception. And this is where the generic comes in. Instead of casting to a dog, we're just going to cast it to T, which is whatever it happens to be. And we're going to create loaded object rather than loaded rover. And finally, we return the loaded object after we've closed the object loader. This gives me a warning, and this is because this isn't the neatest way to do this. I know this can cause problems because if you tell this to load a dog as a cat, it will try, and it will throw out some errors for trying to do it that way. So this requires a little bit of sanity on behalf of you actually implementing your saving and loading. But now I can replace this gubbins here with loaded rover equals load object Rover.dat. And because of the generics, anything, this will load this to be any class. So just to prove that all we've done here is moved some stuff out of try blocks into methods, everything still runs like it should. So just before I end this tutorial, there's one thing that I want to make really clear, and it's the biggest place that errors will pop in. So if you don't have this clear in your mind, you will start to create problems when you're following your intuition but not really paying attention to what's going on. So the thing you need to watch out for is that the rover that we save and the rover that we load look identical, but they are not the same object. And the way we want to show this off is rover is not equal to our loaded rover. In fact, when I run this through, you see at the bottom here we get a little false. Even though they're both called rover, they both have the same age, and it feels like they should be the same object. They exist in different places in memory. If I take loaded rover and I change its age to 6, so he's had a birthday, we can see that rover's birthday remains 5, whereas loaded rover turns to 6. Just so it's clear, this also doesn't change anything about the file. The file's been created higher up. This is not intelligent enough to update the files when I change the objects. So don't forget, when you load an object, it's not the same as the objects you have in memory. It creates new ones. Otherwise you might end up getting in a mix. The easiest way to deal with this is to do all your saving at the end of a program and do all your loading at the start. It's very rare that you'll want to save something to a file and then reload it before you've quit the program. But keep this in mind. So aside from that, that's the very basics. There are more things that you want to keep in mind. Bear in mind, you might, instead of having your dogs just reference strings and ints, they might reference other objects that you've implemented. So let's say we have a squeaky toy. These need to be handled down the line. But for now, that's the basics of saving an object to a file. If necessary, I will go into some of the more in-depth things to consider saving complex objects or objects that reference others. Hope this has helped. If you have any questions, just ask. And thank you very much for watching.